let us say we could able to process 1 billion rows of data on 64 CPU box, yeah, and let us say 1 trillion on 512 CPU box. What if you want to process more than that? So we cannot process more than that by using even SMP also. So in that case, how are we going to solve that particular problem? To solve that, we can think of using what MPP hardware environment, where you will have n number of physical boxes like a box 1, box 2, box 3 and so on, which are interconnected in order to meet what we call final any kind of requirement. So we don't have any limitation with respect to hardware. You know? So all of them will be resolved by using this particular MPP hardware environment. Remember, yeah? Yeah. So the main purpose of this particular hardware environment is what? To get degree of parallelism. Let us say if you want to process 1 million records in let us say 10 minutes. Normally if you run it in a single host system, it would take let us say 2 hours. Now you want that to be processed in 10 minutes. So to do that, first we need to think of using SMP hardware environment. That's our first problem, and that can be solved by using this hardware environment. Yakut. Why it is needed datastage? Because ultimate goal of any ETL tool, including datastage, to process large volume of data in short span of time, right? To do that, we need to have enough hardware to take care of that. This is one such hardware which is SMP, which means symmetric multiprocessor, which can be used to solve that particular problem, where we can process a large volume of data by adding more number of CPUs, and each CPU is going to share what you call part of the task. So if we combine all the CPU what you call operations, then as a result of that we could able to process very large volume of data. Okay? But if you go with a single CPU, there is a limitation, right? Beyond that we cannot process. So that will be solved by using what you call adding more number of CPUs, and then as a result of that we could able to process large data. Yeah, good. Yeah. Main purpose of this is what symmetric multiprocessor. Yeah, symmetric, which means what? Each CPU will be symmetric in nature. Symmetric multiprocessor, which means what? That's a CPU or core. Yeah. Each CPU will have two cores which we call virtual cores. So we can say that is going to be the processor more than one. So that's what we call symmetric multiprocessor. That's the expansion of SMP. Yeah, good. Now if you take any hardware, let's say IBM hardware and also HP hardware vendor, where they cannot support more than let us say 256 CPUs or 512 CPUs. But what if we cannot able to process by using 512 CPUs? Yeah. So there is a limit, right? So to do that, we can add multiple physical boxes. Here, this is a complete thing is what one physical box which contains n number of CPUs. But here in MPP, which is massively parallel processing, yeah, where we can have multiple physical boxes which will be interconnected through high-speed network. Yeah? So we can say that each physical box is going to be the separate what we call computer. Yeah, it's like what you call each physical box is what you call a separate SMP, which means it is a set of SMPs which are interconnected through high-speed network. Yeah. So for example, if just by using this, if we could able to process 1 trillion rows of data, then if we add one more, then we can have 2 trillions. If you want to process 10 trillions, then you can add 10 physical boxes. If you want more than that, keep adding more physical boxes. So which means what? You will not have any limitation if you use MPP to process very large volume of data. Yeah. So irrespective of number of records, we could, if we use MPP, we will not get into any issues while processing very large volume of data. Clear? So that is where MPP is the best choice while designing any what you call data stage, and underlying hardware is going to be what? MPP, rather than either this or this. There are some customers who are using this, and there are many customers who would go with what I call MPP, yeah, which is massively parallel processing hardware environment. Yeah. This is what we have. Yeah. Now within this MPP, we have what we call flavors of MPP. Like we have a grid, we have a cluster. As you guys would have seen, data centers where most of the guys will be using what is a clustered environment, where each cluster or each box is separate, or each of these boxes will be connected as in the form of what is a cluster, so that we could take care of processing large data. Yeah? So most of data centers, people would be using clustered environment, and grid, especially for data stage environment, we would be using grid because of what? Because of uh, computation of what we have within this grid, which means we don't need to take care manually, like in order to utilize all the resources. Yeah? But if you have grid environment, then it itself will take care of like how well we can utilize the resources effectively, which will not be the case with a simple MPP. Remember, yeah? So that is why grid has become more popular in order to what we call take care of processing very large data with the effective utilization of resources, which is what happens with what we call grid environment. Yeah? And if you look at this hardware, like let's MPP, right? And we have multiple physical boxes, right? If you want to make this disk to be shared across different physical boxes, then we can start making use of what we call this SAN environment, which we call storage area network environment, so that we could be able to share the resources across what we call physical boxes. But it is not mandatory that we need to use SAN, which is storage area network. We can use what we call lesser, even other networks also, like low speed network or medium speed network or high speed network. If you use SAN, then you'll get what we call sharing with respect to disk storage area network, right? So which means what we can have shared or distributed shared system by using SAN, which cannot be achieved with normal network. So that is why some environment or most of the environments people would go with what? SAN, storage area network environment. Yeah? But in MPP, remember, each physical box will be on its own, which means what? Each physical box is like a SMP, which means it will have its own disk, it will have its own memory, it will have its own CPUs. Yeah? And similarly, if you take other box, you'll also have similar set. So the resources of what we have in this physical box will not be accessible in other physical box. So each box is going to work on its own. Yeah. So how are we going to what we call take care of uh, making use of these resources effectively? That's where MPP will be used for. But the question here is, this is what we call shared nothing architecture. The reason is what? Each box works on its own. Yeah. But datastage has got a very good way of what we call configuring different physical boxes so that each box can be utilized effectively. That is where node configuration would come into picture. Yeah. Using node configuration, we can utilize the resources effectively. Yeah. So that will be taken care by data stage, which we don't need to worry. We just need to know like how to configure these nodes properly. Yeah. So that we can utilize the resources effectively. Yeah. So node configuration is going to play a key role so that uh, because of that only what we call distribution of data is going to take place across different physical boxes. Remember, see, if you want to get good parallelism, we have to think from software perspective and also from hardware perspective. Both should be there. Just by having parallelism within our data stage, that alone will not be sufficient. We also need to have what we call sufficient hardware so that we can get good degree of parallelism. Yeah? Clear? So that is what we have with respect to what we call parallelism part. Yeah? Now, let us think from the data stage uh, parallelism techniques where we have pipelining parallelism and also we have partitioning parallelism. Yeah? I repeat, there are two types of parallelisms in data stage. One is what we call pipelining parallelism, other is what we call partitioning parallelism. Yeah? Now, pipelining parallelism meaning what? Let us say we have one task and another task, yeah? And now we need to process 1,000 records. So if you look at the traditional approach, this guy needs to process all 1,000 records. After successful completion of that, then only we can get into what we call next task, which is enrich or whatever. But in data stage, it is not like that. So we could define a buffer size, a transfer block size. There's a block size can hold. There's 100 rows. Then this guy processes 100 rows, he'll place it into the buffer, other guy will pick it up. And by the time it sends 100 rows, at the next set of 100 rows, this guy will start getting it processed. Which means what? We are making every process busy. So we can say that we can run this and this and this all in parallel. So that is where this pipelining parallelism would come in. Meaning a downstream stage, this let us say one of the stage here, and upstream stage is this. So downstream stage need not have to wait till all the rows that should be processed by the upstream stage. Yeah. So which means this guy, it doesn't need to wait till all 1,000 rows that should be processed by this. So as and when it processes first 100, then it can put it in buffer. This guy will pick it up. By the time it sends it, next chunk of 100 it will get processed. Then by the time this guy finishes second chunk, this guy is ready to process what I call next set of 100 rows. Likewise, both in the sense this and this, both of them will be up and running in parallel. As a result of that, we are going to get what we call pipelining parallelism, which means what? Several tasks which will be up and running simultaneously. Yeah. So as a result of that, so we can get parallelism, which we call pipelining. Yeah. But if we go with a traditional thing, this guy need to process completely, and then only we can get into the next one. So which would take a lot of time to process large volume of data, right? So that is why pipeline is one type of parallelism where we can solve that particular problem. So as a result of that, we can avoid using disk, which means output of this fast need not have to be stored onto the disk, and this guy need not have to take it from a disk. So we are avoiding usage of disk. And next thing is what? We are making processors and processes busy, which means what? If we run two software stages in parallel, so this guy will make us over one CPU, this guy will make us another CPU. As a result of that, we are also making processors corresponding each process busy, so that you'll get what we call good parallelism advantage, that we call pipelining. Yeah? So this will be repeated for n. If we have n number of stages, all of them would be what we call up and running in parallel. That is what will happen in pipelining parallelism. Yeah? Now, there is a limitation here. Let us say if you have 1 billion rows, then what happens? What happens here? We can only process what we call based on the buffer size, right? Yeah. But how are we going to utilize multiple boxes, like what I was trying to talk here? Let us say, let's take this case. How are we going to utilize multiple physical boxes effectively? Which means what? Here let us say out of 1 billion, one third of 1 billion, one third of 1 billion, one third of 1 billion. Can we do that? Splitting the data for these three physical boxes equally? That cannot be achieved by using what? Pipelining parallelism. To do that, this partitioning parallelism would come into picture, where we can divide the input data into multiple subsets, which means like a one third is for the first box, second box one third, third box one third, and so on. If you have more boxes, then we can divide input data. So that is where what we call partitioning parallelism would come into picture. So each what you call box, again you will have what you call pipelining. So if you look at this parallelism, let us say combined parallelism, so you'll have what you call both, which means partitioning as well as pipelining will go hand in hand. That is why datastage has become more popular with respect to this parallelism advantages. Yeah? Clear? So which is what happens in datastage. Clear? Any questions over here? Any questions over here? Yeah. In real time, MPP is the most widely used one. Then second is what this one, SMP, with respect to hardware. But in parallelism, with respect to software, every what you call hardware environment, you will have these two parallelism techniques by default. Yeah, good. So that's what happens. Yeah, the question is, yeah, are the records are going to get distributed equally? Answer is it depends. It depends on kind of parallelism that we are going to use, Shilpa. So, for example, if you use if you use what you call one partitioning technique, let us say a hash, then uneven distribution. If you use, let us say, what you call round robin, some cases it will be even distribution. So this distribution will not be guaranteed. So but that will be based on what? Hash partitioning. That is based on partitioning method that we are going to choose. And based on that, distribution is going to take place. Shilpa? So that's what happens. Any other questions? I'll just unmute so that you guys can speak out. Fine. Okay. Now, if you think, let's say, different types of parallelism techniques, partitioning techniques, we have what you call round robin, hash, entire, same, auto, and we have some more. If you look at these broader categories, we have two types of broader categories. One is keyless partitioning method. Second is key-based partitioning method. So we have two types of partitioning methods, yeah, broadly. So keyless partitioning methods where we are not going to use key for partitioning the data. So round robin is going to work based on what time slice. Yeah. For example, if the first process is going to take 2 seconds, if it's going to process 1 million records, it could. Or else, as soon as this 2 seconds gets over, immediately operating system scheduler, the task will be handed over to the next process. So which means what? Based on the time slice, what we call round robin algorithm or partitioning method is going to work. Yeah. But in case of this entire, yeah, especially if you go with the MPP, like what we discussed, in that case, every box you will have what we call complete data. If you have 1 billion records, you'll have 1 billion records in one each box. Yeah? Which means what? We cannot share what we call, or we cannot distribute the data like 1 billion by 3 or 1 billion by 4, because the entire means what? It would expect complete data to be available on each box in memory. Then only we can think of using what we call entire partitioning method. Remember. So which will be used especially if we use what we call lookup stage, yeah, where it expects all the rows to be available in the lookup table or reference table, so that that data will be taken as a reference for what we call to perform lookup, which means you have reference data, all the records. Those records will be checked against with source system data. Based on that, lookup will happen. Yeah. Similarly, we have same partitioning method where if you have two stages, if the stage 1 is going to make use of round robin, stage 2 also will make use of same round robin partitioning method. Yeah? So if you use same, but we can have one partitioning method for one stage, other partitioning method for other stage. So we can have different partitioning methods depending upon the kind of logic that we are going to build, right? Based on that, you will have. No, this should be done by developers, Yakut. Is a good question from Yakut. Is this would be done by administrators? Answer is developers. Yeah. So developers need to do these activities, which means what? What is the right algorithm, right partitioning method for meeting any business requirement? For example, let us say you need to group set of related records based on customer type or based on any key. Then in that case, we need to use hash partition method to meet that particular requirement. Right? So developer need to do that. Like as you said, ETL developer, right? Yes, ETL developer need to configure what we call appropriate partitioning method. Yeah? So in case if we have too many records within each group, in that case we can think of using what we call modulus partitioning method, which is what will happen with modulus partitioning method. And then which means what we are going to divide what we call hash partitioning method divided by total number of nodes. Nodes means what? These are the nodes which I was trying to talk. So which means what? Nodes means what? If you want to obtain good degree of parallelism, then what we need to do is we need to start adding more number of nodes so that we are going to get proportionate degree of parallelism. That's what will happen with this particular configuration file. So which means what? If we add more nodes to process large volume of data, you will get proportionate degree of parallelism. Like you can see here, if we add 8 nodes, then you will get 8 times performance advantage. If you get 24 nodes or 24 processors, then you will get 24 times performance advantage. So that will be achieved by using what? Configuration file, which could see over here. Remember, this partitioning parallelism will be achieved by using configuration file. Without this, we cannot divide this input data into multiple chunks. Can you see here? Node 1, node 2, node 3. From where you will get that? From node configuration file. Node 1, node 2, node 3. So each node can be a logical node or it could be a physical node. Which means what? If you have 2 CPUs, per CPU we can have 2 logical nodes. That's the best practice. If you have 4 CPU box, maximum we can have 8 logical nodes, though it is the same physical box. Similarly, we can also have each node separate physical box name also. Within that we can have n number of CPUs, and each CPU if you want to utilize, then we can have that many number of what we call logical nodes. Best practice, per CPU we can have 2 logical nodes. If you add more than that, you will not get performance advantage. Instead, it is going to degrade the performance. Just remember. That's what happens. In what we call parallelism part in data stage. So once we do that, then we can get into what we call other partitioning techniques, like we have what we call DB2. As I said earlier, DB2 partitioning technique is good for DB2 what we call stage, and but if we use it for what we call other stages, it's not that great, but it is okay. But use or most widely used partitioning type is hash, entire, same. These are the most widely used what we call partitioning techniques in real projects. Yes, that's a good question. The question was from Yakut, is there any hard and fast tool to divide the data, or we can do it based on depending upon the volume of data? Yes, we can divide based on volume of data by using different number of nodes. If we have 2 nodes, that's 1,000 records, then 500 records for each node. If you go with the equal distribution. But again, whether it is going to 500 records or 600 records, that would be based on the type of partitioning method that we are going to choose. For example, let us say there is a key which is a customer type. Customer type, prepaid customer. Customer type is equal to postpaid. All the prepaid customers will be sent to one partition, all postpaid customers will be sent to other partition. Yeah. The count of prepaid customers might be less or more than postpaid, right? So in that case, equal distribution is not going to take place. In one partition there could be 400, other partition there could be 600. So that's an example of what I call uneven distribution. Yeah. So randomly it is going to distribute the data depending upon your type of partitioning technique that we are going to choose. I just gave one example like a hash key. Yeah. Yeah. That's what happens with what I call this particular partitioning techniques. Yeah. So let us start getting into what I call some practical examples. Yeah, so now let us start, like we discussed about how the aggregator stage is going to work. So aggregator stage will be used to perform different aggregation operations, like we have what we call sum, average, count, standard deviation, variance, and so on. Yeah. And copy stage also we have discussed, which will be used to distribute the data from one input link to multiple output links. Yeah. Now we will talk about what we call other stages like filter stage. Let us say you get 1 million records. Now as per the business need, you need to focus only, let us say, part of this 1 million records based on a filter condition. Let us say filter condition is going to be based on what? Prepaid customers, which means the customer type equal to prepaid. Only apply business logic for prepaid customers only. So how are we going to build such type of filter condition? That is where filter stage is going to help us on doing that. Yeah. Let's use input, which could be what I call any source, or it could be row generator, and then we can use filter stage, yeah, using which we can start limiting the number of rows, and then target can be what I call a sequential file stage, where you can dump output of this filter to a sequential file. Yeah. Let us start connecting this row gen to filter, filter to sequential file, which is what need to be done just to start with. Yeah? And then define or configure the properties for each stage. Yeah, we can start using what we call column 1, and then which is of type, let's say, integer. Yeah. And likewise you can add any number of columns over here. Yeah. Column 2, which is of, let us say, varchar. Yeah. So assuming that we added 2 columns over here. Yeah. Now by default you will have what you call 10 records, which this guy is going to generate, right? Now we need to apply a filter in such a way that I just need only the records based on our own filter criteria. To do that, we can start making use of filter stage. Yeah? Let us build a filter condition, which is going to be the where clause, yeah, through which we can limit the number of rows. Yeah. So we can define here C1 less than 4. then what will happen? If this particular column value, which is C1, where the values are less than 4, only those records will be transferred to what? To a target, which is what will happen because of this particular filter condition. Now, what we call, send this output of this filter condition to a target, which is going to be again a file. You can specify here output followed by seq underscore filter dot txt. That's it. So which means we are going to send what we call filtered data to a target. What happens to other records? They will be ignored by default, but if you want to capture them also, we could do that. I'll talk about that in the next example. Okay. Now it should be okay, right, Venetia? No, I think it's a muting problem. Now it should be okay, Venetia. Is it fine now? Yeah, now I muted all of you guys, so now it should be okay. Oh, it's not okay? You can just log off from the GoToMeeting and log in back, Manisha. Yeah, so which is what we will do, what you call as part of what you call building this particular filter stage within this particular job. Once we do that, then the next step is what we can just compile and run, look at the output and see whether we are going to get expected output or not. We will get it. Now the next thing is what next thing is going to be what if you want to what you call, yes, just give me 1 minute. So what if you want to, let us say, capture multiple output targets, which means what? Let us say I want prepaid customers in one target, postpaid customers in one target, other than two types of customers in another target. How are we going to take care of that? To do that, we are going to use what we call multiple filters over here. I repeat, we can use multiple filters. As a result of that, we can now transfer the data to a target, which is what will happen over here. Let us start doing that. So now we know, let's try to compile this, and then after that we will get into the next step. Yeah, let us try to save it. Yeah, let me read. Yes, we can have any number of targets, Yakut, like it could be sequential file, database, or external application, or it could be what you call any database. So mainly there are three: file, or application, or database. one of them. But with respect to number, any number of targets we can have. There is no limit. Like in filter, in Informatica we can have only one. But here we can have more than one. So we can say that this filter is equivalent to router transformation in Informatica. Yeah, good. Router we can have multiple subgroups. Each subgroup we can have corresponding target. Similarly, each filter criteria will have corresponding target. Yeah. Now run this particular job. Yeah, let us open director. Anyway, we can just see the statistics here itself. If it is a green color with arrow which indicates this job has been successfully compiled. If not, there is something wrong. Blue means what? It is running. Huh? Yeah, let's go to target, which is a sequential file, and see whether we got the data to that particular file or not. Yeah. So this is a file, right? So we'll change the file name. Yeah, same. Yeah, drag and drop only. Interface wise, more or less same, like what we do in Informatica. Yeah. So exactly same. So all the ETL tools, they're all drag and drop. Yeah. Right, you are right, Akrit. Yes. Row generator is a source, filter is a transformation, target is a file. Yeah. Now we could able to see what we call just got executed, right? Green line with arrow indicates successfully completed. Now we could able to see the data in the target. This is the one, right? So records which matches this particular filter criteria, you will see that. Can you see here? 0, 1, 2, 3, 4. That's it. Yeah? Because 0 is less than 0, 1, 2, 3, right? Where the values are less than 4. So that is why these 4 rows have been transferred, though we have 10 rows. So likewise, we can add some more filter conditions in order to look at what we call output in some other target. Let us start doing that. So for that, we can add one more where clause where, let us say, we can specify C1 greater than 7, which means what? 8, 9. Those records will be transferred to one more target, which is going to be, let us say, one more sequential file. Let us drag and drop and connect filter to sequential file stage and define the second file, which is going to be the second where clause output. Now, which target will have what? How do you say that this will have greater than 7, this will have less than 4? To answer that, there is a link ordering within this filter where we could able to see what we call which link will have what where clause. 0 is the first link, second link is what? 6, which means what? We have defined, this indicates what we call 0, which is the first target. This is going to be the second target. If you want to change the order, we can always change it. Like if you want to send this to what you call, 0 will be sent to 6 and 1 will be sent to 4. If you want to do that, we can do that. So which means by default you will have, if you organize from top to bottom, this will have first link output, this will have second link output. But actual thing that you will get it from link ordering. Now save it. So which means we can save this to multiple filters. Oh, okay, fine. So now you will have the first condition output over here, second condition output over here, which is what you will see here. Let's compile and run. Yeah, can you see here? Here we have two rows that have been transferred here from filter to this guy, which is second filter. This is first filter, which we have already seen it. Now we can go and look at the data here. Second filter, this one, right? Where we'll have two rows. 8 and 9, which are greater than 7, right? So this is how we can capture data in multiple targets depending upon the filter condition that we are going to define within this particular filter. But what happens to other records? Which means how are we going to capture the records which does not matches with this particular filter condition? That is where we have concept of what we call reject. So reject option will be used in order to capture unmatched records, which means here we have 4, here we have 2. What happens to rest of what we call 4 records, total 10 rows, right? So those 10 rows can be captured in a reject link. So for that we can add one more target and connect from here to this guy and then we need to enable output regex is equal to what? True. Yeah. So once we do that, then the records which does not matches with these two filter conditions, right? Those records will be sent to rejected link. Yeah. Here we can specify what rejected file. That's so this is what we do, and then say okay. Now you'll have what you call in this particular target, you'll have the records which does not matches these two filter conditions. Yeah? Now save it, compile and run. Yeah? Now we have what you call missing reject link, which means what? Output rejects we have not configured correctly. Output regex is equal to true, that is fine. But this link is what? Normal output link. What do we need to do? We need to convert this to reject, which means dotted line with arrow, which indicates what? Reject link. So that need to be configured. Now compile and run. Yeah. Yeah. Can you see here now? Here 4 rows, here 2 other records, right, which does not meet filter criteria, right? These two, those records will be sent to this particular file. Now we can go look at unmatched records in this rejected file. Yeah, can you see here 4, 5, 6, 7? These records are not satisfied with any of the filter condition. That's it. So that is what happens with what we call filter. So we can add any number of filter conditions and then add what we call corresponding targets so that we could able to capture output in respect to targets, yeah, depending upon the filter condition of what we define. Yeah. So alpha bits we have it, that is for the second column, which is column 2, where we have defined what? Varchar. Manisha, let me show that. First column we have what? Integers, and second is what? Varchar. So it is going to generate what we call random data for variable characters. Yeah? So that will be done by the row generator automatically. Manisha? And first column is what? C1, which is integer, which means 0 to 9. Yeah. So if you go look at this view data here, you can see like what kind of data that was generated by this row generator. Yeah. Fine. Yeah, which is what happens here. Yeah. Now this is what we call the data, which this guy generates. First is what we call C1, second is C2.